translation machines. So we have two machines. One is called Sophia and translates lots of words from English to Greek. The other one is called Shokma, and it translates lots of words from English to Hebrew. So we just have these abbreviations, ENG, GRE, ENG, HEB. The first machine words usually got longer, and on average, the scaling factor was 1.22. In the second one, words typically got shorter. The scaling factor was, on average, 0.79. So we're being asked how to use these two machines to build a new one to go from Greek to Hebrew and be creative as you can. And then the second question is, what would be the approximate scaling factor for this new machine? So, and show it why. So yeah, welcome to meeting 4. So this is part 1, the last challenge. This is optional. If you're running short on time, you may skip it, leave it as homework, or as we recommend, sometimes just do it kind of fast together as a way to close this part. So you have some flexibility there. Okay, so for the solution, let's go to the teaching manual. And this is really a lot about being creative, the first part, and just think what to do. We want to go from Greek to Hebrew, so just using these two machines wouldn't work. So here's Greek. Let me copy here so that we don't forget, because we really want to go from Greek to Hebrew. So we want to build a single machine. Okay, so this first part is half mathematics, like pure mathematics in the sense of a unique answer and just abstract. And the other half is just open and just be creative, just maybe engineering or just creativity in general, just to have kind of fun and to see what students give you. So it's a nice mix, I would say, between open and closed. But nevertheless, you want that students realize that if we want to use this this first machine, Sophia, we really want to make some inverse. Because really for this guy here, I could just put it, right? And this would do the second part of the job, right? Now I want to go from Greek to English. And here I just go from English to Greek. So using creativity, either just call the scientist or the engineer who made this machine and ask him to do the reverse machine, or just come up with some algorithm that would allow you to invert, maybe by looking at all the samples. And some discussion there. That's kind of speculative, it's fine. And anyways, you end up inverting this guy here. And so it's another type of machine. So let's maybe give it another color. It's something new that instead of going from English to Greek, goes from Greek to English. And since English is here, then you just paste it. So what you end up doing is Greek and this English. So yeah, you may recognize this as function composition, but you don't have to talk in that language for the students. But you're really pasting two machines, inverting one, reversing what it does. And then this would be the case or the result. And so it's just one, you can view it as just one machine that goes from Greek to Hebrew. So this could be like a black box step, like you don't really care at the end, or the user. The user doesn't know that it goes through English, just takes a word in Greek and waits for a minute or so and gets this output in this Hebrew language. Now, let's talk about the actual answer for the second part, which is the scaling factor. And so students may guess maybe that the scaling factor is 1. I don't know, because maybe this kind of balances out, because this is 22 and this is 79. But that's wrong on many levels. But it's very interesting if students go like that, because then you have a lot of chances to discuss with them and make sense of them, of it, so as to explain. But so what happens is, let's see, if this machine had 122 and this had 0.79, then this we didn't touch, so it's still gonna have 0.79, which we can really approximate to 0.8 or 4/5, right? So that would be okay. That's the scaling, makes words shorter by 20% less, right? And then Greek to English, well, we actually had Sophia with a longer 1.22, which is approximately 1.2 or 6/5, or 125. You could also work with 5/4. So either way is fine. And maybe take this 1.2. So either is okay. And then students should realize that when you invert, this 1.2, sorry, is not gonna become really 0.8. And that's very interesting in relative growth. The inverse of increasing 20%, to go back, is not decreasing 20%, right? Let's make an example. If I have something that's a word that's 10 and I increase it by 20%, then now the length is 12. If I decrease it by 20%, well, 10% is 1.2, so 20% is 2.4. So I will have to subtract 12 minus 2.4, and that'll be 9.6. So it's not the inverse. The inverse of plus 20% is not minus 20%. So you can discuss that. What is going to happen is that it's the inverse fraction, because that's what happens when you multiply back 6/5 times 5/6. That's 1. So 5/6. Yeah, we can also work with the decimal, but let's just work with the fraction just to really concentrate on what's going to happen here. And then these two machines get shorter first, but gets shorter first, because Greek is really long compared to English, and gets even shorter now to Hebrew, because Hebrew shortens the English in terms of the characters, the letters. So you end up multiplying 5/6 and 4/5. And that's kind of easy, because then the 5 cancels, right? So 5/6 times 4/5. So you end up with 4/6, right? You can make a diagram illustrating that you can forget about the English. It's just a step that you don't see, or the user, whoever uses the machine, doesn't care, doesn't see. And it's going to be, as we said, 4/6 or 2/3. Or in percentage, it's a reduction of 33%, or it's a scaling of 66.6%. So a word of length 10, it's now going to be a length 6 or 7 on average. Does it make sense? This number is small? Yes, because it's shorter and shorter again. It's a composition of two processes that shorten the lengths. And so that would be the answer. Lots of discussion, lots of opportunities to explain concepts, misconceptions, even go back to these examples of the English and Spanish. And so, yeah, have a lot of fun in these machines. You can also say a few things about these two languages, of course. So have a lot of fun, and see you in another video. Goodbye.